This is example 13.4 from Discovering Design with Chemistry. Water has a latent heat of fusion of 334 joules per gram and a latent heat of vaporization of 2,260 joules per gram. If 150 grams of water freeze, how much energy is involved in the phase transition? Is the energy absorbed or released? So let's start with the first question. In the book you've just finished finding out about this equation, so it's pretty straightforward. We're just going to start with that. So Q talks about heat or energy. So our mass of water is 150.0 grams, and our latent heat of fusion or vaporization, and that's where we have to decide which one we're going to use. Because it is water that is freezing, that means if you're using something where water is freezing or a frozen thing is unfreezing, we're going to use the one with an F and an L of F. The other number doesn't matter, they just threw that in there to mess with you. So 334 joules per gram. So our units cancel, which is great because we want to be left with joules. And then we just multiply these. Now we have 4 and 3 significant figures. So I'm going to remind myself that I need 3 significant figures when I start getting my answer. Alright, so I only get to keep 3 of those, which is fine because 5, 0, and 1 are all significant. The 2 zeros aren't significant, so I can write it just like it has. So 50,100 joules. Alright, so that answers the first question. That's how much energy is released. Energy is often measured in joules, so that works out perfectly. The next question says, is it absorbed or released? Well, we're going from liquid to solid, or we're going from water to freezing. If the water is getting colder, the things around it are going to get warmer. It's going to make its surroundings warmer or heat up its surroundings. So that means it's releasing energy. So the answer is released. So here's our first answer for question 1, and then release is our second answer, or our answer for the second question.